Central facial palsy, colloquially referred to as central 7, is a symptom of finding characterized by paralysis or paresis of the lower half of one side of the face. It usually results from damage to upper motor neurons of the facial nerve. The facial motor nucleus has dorsal and ventral divisions that contain lower motor neurons, supplying the muscles of the upper and lower face, respectively. The dorsal division receives bilateral upper motor neuron input, i.e., from both sides of the brain, while the ventral division receives only contralateral input, i.e., from the opposite side of the brain. Thus, lesions of the corticobulbar tract between the cerebral cortex and pons and the facial motor nucleus destroy or reduce input to the ventral division, but ipsilateral input, i.e., from the same side, to the dorsal division is retained. As a result, central facial palsy is characterized by hemiparalysis, a hemiparesis of the contralateral muscles of facial expression, but not the muscles of the forehead. Signs and symptoms. Central facial palsy is the paralysis of the lower half of one side of the face. This condition is often caused by a stroke. This condition is often the result of damage of the upper motor neurons of the facial nerve. The facial motor nucleus contains ventral and dorsal areas that have lower motor neurons that supply the upper and lower face muscles. When central facial palsy occurs, there are lesions in the corticobulbar tract between the cerebral cortex. Because of these lesions, the facial motor nucleus reduces or destroys input in the ventral division. The ipsilateral input in the dorsal region is preserved. Central facial palsy is often characterized by either hemiparalysis, a hemiparesis of the contralateral muscles in facial expression. Muscles on the forehead are left intact. Also, most patients have lost voluntary control of muscle movement in the face. However, muscles in the face involved in spontaneous emotional expression often remain intact. Central facial palsy occurs in patients who are hemiplegic. Such patients not only have dysfunctions in the facial expression but also a difficulty in communication. Other oropharyngeal functions such as sucking, swallowing, and talking are also impaired. Central facial paralysis palsy often has similar characteristics with stroke patients. Because of uncrossed areas from the ipsilateral and the supranuclear areas, movements in the frontalis and upper orbicularis oculi are often spared. Facial movement can be present on the affected side when the person expresses emotion. Damage to the central nervous system motor pathway from the cerebral cortex to the facial nuclei is found in the pons. This leads to facial weakness that spares various muscles in the face depending on the type of paralysis. The discrepancy of the weakness between the upper and lower facial muscles are due to the bilateral corticonuclear innervation from the upper facial muscles and contralateral corticonuclear innervation to the lower facial muscles. The motor system and facial patterns. In contemporary perspectives, the motor cortex is composed of two distinct areas. However, this viewpoint is incorrect. The motor cortex is located in the posterior frontal lobe and has multiple areas with anatomical and functional regions. Each area is involved in the circuitry of various inputs of sensory information. The motor and parietal areas are reciprocally intertwined and form a group of specialized circuits that work parallel to one another. These circuits transform sensory information into an action and movement. The parietofrontal circuits are the basic compositions of the main elements of the cortical motor system. These circuits depend on the motor area to receive afferent information from the parietal areas. The input in one area is predominant, containing full amounts of information. The other input area is known as moderate to weak. When the input is moderate or weak, it contains additional secondary information. Each parietal area is connected to several motor areas. However, it only makes privileged contact with one motor area. Exceptions to this include the prefrontal gyrus, where the parietal area sends an equal amount of fibers to many motor areas. This interaction is vital because the activity in the facial muscles is due to voluntary control.